Hello everyone and welcome to lesson 6.2.4. What sequence makes them the same? Today we are going to be putting together all four skills. Translation slide, a rotation which is a turn, a reflection which is a flip, and a dilation which makes an object bigger or smaller by multiplying. So today we are focusing on congruence. We're trying to make sure that the shape is congruent as we work through those slides, flips, and turns, and then it's going to turn similar, okay, when it gets bigger or smaller. So notice 6-76. Copy the graph below. You have this in your math notebook. Please notice that you have lines off to the right-hand side. We have a couple things that we have to do. Question A, do you think the figures are similar? Similar means that they follow a pattern, right? So if I were looking at A and B, I would try and look for patterns that make them similar, things that I need to recognize. Are the angles the same? I notice this shape is right angles. So I can say, okay, that's a good start. I notice that shape A, its short side is 2, and B's short side is 4. Those follow a pattern there. What about the long side? The long side is 4, and the tall side is 8. That shows a sense of similarity, right? Because you notice a pattern going here. So for letter A, off to the right-hand side, label A. And I want to say, yes, they seem similar because the short side is half the size of B's short side, and A's longer side is half the size of B's longer side. Okay? That sense of similarity seems to be there. The main work that we need to do is in B. Describe a sequence of transformations, reflections, rotations, translations, to turn A into B. We got to turn A into B. So what we need to do, and I'm kind of working with you on this first one to try to get A into B. So here we go. The first thing that I want to do is a rotation of 90 degrees, and I am going to go clockwise. Okay? Now when I do this, you are going to turn on this point. Maybe I should include that. At -2, -2. Now when you're doing a rotation, you need to think about where this edge is going to land. Right? If I'm going to take this 90-degree angle and I'm going to rotate it up here, 90 degrees to this line. So if that's where it's going to land, I need to think, okay, well, this long side is going to land right there. So I should go ahead and draw that side. Now this bottom edge is going to swing 90 degrees there, so it's going to be on the bottom there. So let's go ahead and draw that in. There's the bottom edge, and hopefully you can see the rest of the shape is going to be right there. This is after a rotation off that corner, -2, -2. Now, the question is, I know that I need to get A to B and get it dilated, but we need to remember something about when we dilate. Not only do the sides get larger, but the distance from 0 also increases. So you have two choices. You can translate, get it to 0, or you can translate it to the right spot. See, this is where I like to teach chess, because chess is about strategy. And we use strategy in mathematics for efficiency. In your real world, you're probably not going to do this. Are you ever going to utilize strategy to be more efficient? Absolutely. I am super lazy. I mean efficient, right? So here we go. If I notice this bottom corner is at 2, -2, and I also know I am going to dilate it times 2. If I'm going to dilate it times 2, I need to work backwards and think, if this is twice the distance from 0 after dilation, where is the halfway mark? Well, half of 2 is 1. This is called deductive logic. You use what you know to figure out what you don't know. So what I'm going to do is I am going to do a slide. I am going to do a slide. How many is the x? I need to do x plus 3. And I need to do y plus 1. Oh, I'm working off the wrong corner, Mr. McCoy. Remember, mathematicians make mistakes too. I need to get that bottom left corner. My apologies. I need to get the bottom left corner over there. So that's now x plus 5. I'm glad I caught that. X plus 5 and y plus 1. That's going to take my shape A apparently I got to move this in parts. My shape A is going to move there. Okay? Now I'm ready for my dilation. I'm going to dilate times 2. Now this dilation of times 2, notice the distance from 0. Notice that this is at 1, 3, and now it's at 2, 6. Notice this point, -1, -1, and now it's at 2, -2. Notice 3, -1, and now it's at 6, -2. All the coordinates got 2 times bigger. That's the emphasis in a dilation. You would have to work out your coordinates and multiply them by 2. You've got a hand up on this situation because Mr. McCoy knows the answer. I've done this before, and so I know what to expect. And that's what I'm trying to teach you, is make the... Sorry for the interruption. Please make these anticipation of what's going to happen. Okay, problem letter C. How does your sequence of transformations prove that the shapes are similar? When we do these shapes, maybe we should say, when we do these transformations, the slide and the rotation maintain. Boy, we're just doing great. These transformations, the rigid transformations, maintained the congruence. They were exactly the same. But when we multiplied everything by 2 in the dilation, it landed in the exact same spot, which means A is similar to B. Okay? Try and decipher through that, and let's go ahead and write something down for letter C. Pause the video so that you can write an answer to C. Now, you have a blank to fill in for problem 677. Figures that are congruent are the same shape and the same size. You can also say that they have a scale factor of 1. Which transformations can you use to show that 2 figures are congruent? Which transformation will cause the figures that are not congruent but similar? Okay? This is where we had 2 weeks, right? The first week we focused on a slide, a turn, and a flip. Now those have 8th grade words associated with them, but we'll use these words, and those will all result in congruent shapes. Same size, right? Same shape. However, a dilation will result in similar shapes that just look bigger or smaller, okay? So this is a key piece of understanding when it comes to these dilations and rigid transformations. Pause the video so that you can get that written down. Okay, our primary work for today are 3 different problems that are taking you through similar situations, okay? So Angelina and V have made a challenge for you, okay? Begin with figure A, follow these steps. You have Angelina's steps. I'm going to help you with Angelina and you're going to do V. And then what we're going to do is we're going to follow these steps and then we're going to see where it lands, okay? So it says reflect the triangle across the x-axis. Here's the x-axis, and so this shape is going down here. Notice that with a flip, it is 1 away from the axis, so the result is 1 away from the axis. This is 4 away, so it is 4 away. 1 away, so 1 away. And you can draw A prime. Now A prime is just a way to show this is the first move. Rotate the triangle about the origin counterclockwise 90 degrees. So we're going to go this way. Okay? Now think about this. If this is connected to the origin here, and we're going to rotate 90 degrees, that means 1, 1 is still going to be at 1, 1. You rotated it down. If I have this coordinate, -5, -1, instead of this line being horizontal, if it's rotating 90 degrees, it's going to now be pointing down. Notice the coordinate is now -1, -5. Okay, notice the similarities. Notice my coordinate here, -2, -4. And when we rotate this, instead of this being down 3, left 1, this is going to be right 3, down 1. Notice that we're just reorienting the triangle in the new location. Okay? This is a rotation. This strategy primarily works when you're rotating it about the origin. Okay? And you have to think about the coordinates when you do that. Last of all, dilate the figure by a scale factor of half. In order to do this, you need to have all of the coordinates written down. 1, -1, -1. That's going to turn into half, -half, right here. 4, 2 turns 4, 2 turns into 2, 1, 2, 1 right here. And then 1, 5, -1, -5 turns into -half, -2.5. Notice I am just multiplying by that scale factor, which is right here. Notice that my triangle is half the size and half the distance to the origin. So this is the resulting triangle, right? This is the image. And I know it's messy. Math is messy, okay? But notice that we can see the final result. Here's A double prime, and this is A triple prime, okay? This is tough work. What I want you to do is I want you to do your best to do these steps, following those steps, and see what you get, okay? Our final problem for today, now that you have finished V, is scoot this so that we can read it. With your team, find a sequence of transformations that will transform C into D. May I suggest that you do your dilation first? It is so much easier to do a dilation first. Once you do a dilation, then focus on your slide, turn, flip, okay? Do those first. Now, I know that it is difficult to put all these skills together. If you need a refresher on how to do slide, turn, flip, please look at lesson 6.1.4. There are 3 different videos that go along with those 3 transformations. Thanks for your work today, and we'll see you next time.